Welcome to Astronomy Daily, your daily dose of space and astronomy news. Today we're diving into some incredible discoveries and developments from across the cosmos. We'll explore a remarkable hypervelocity star system racing through space at breakneck speeds, uncover new findings about our moon's ancient history, and look ahead to an exciting week of rocket launches. Plus, we'll investigate the physics of tiny black holes, learn about the possible origins of our first interstellar visitor, and discover why some planet-forming disks seem to never grow up. Stay with me as we journey through these fascinating stories from the final frontier. In what might be one of the most extraordinary discoveries of recent times, NASA scientists have identified what they believe to be the fastest-moving planetary system ever observed. Picture this: a star hurtling through space at an astonishing 1.2 million miles per hour, and it's not traveling alone. This cosmic speedster is dragging along what appears to be a super Neptune-sized planet, making this duo the fastest known planetary system in our galaxy. This remarkable discovery was made possible thanks to a phenomenon predicted by Einstein's theory of general relativity called gravitational lensing. The system was first detected back in 2011 when its gravity caused a slight warping of light from background stars. After a decade of follow-up observations using the Keck Observatory in Hawaii and data from the Gaia spacecraft, scientists were able to confirm their finding. The star system is located approximately 24,000 light-years away near the dense central bulge of the Milky Way. What's particularly fascinating is that this system is moving so fast, it actually exceeds our galaxy's escape velocity. This means it's literally in the process of breaking free from the Milky Way's gravitational grip and could eventually become an intergalactic wanderer. While the team has confirmed the star's incredible speed in 2 dimensions, there's a possibility it could be moving even faster, potentially up to 1.3 million miles per hour if it's also moving toward or away from Earth. This would make it not just a record breaker, but a system truly pushing the boundaries of what we thought possible in terms of planetary survival at such extreme velocities. Let's turn our attention now to this week's launches. Space enthusiasts are in for a treat this week with an action-packed launch schedule featuring 4 exciting missions. SpaceX is leading the charge with 3 separate Falcon 9 launches carrying their Starlink satellites, while Rocket Lab rounds out the lineup with their 60th Electron mission from New Zealand. One of these launches is particularly noteworthy as it marks a historic first. SpaceX will attempt to land a Falcon 9 booster in Bahamian waters near the island of Exuma. This new landing zone, made possible through an agreement with Bahamian authorities, offers calmer, more sheltered waters compared to the open Atlantic. This should provide more reliable landing conditions and enable SpaceX to explore new launch trajectories from Cape Canaveral. The first Starlink mission will deploy 23 V2 mini satellites to low Earth orbit, with the veteran booster B1080 making its 16th flight. Meanwhile, Rocket Lab's mission, playfully titled Fasten Your Space Belts, will carry a Black Sky Gen 3 Earth imaging satellite. These new satellites will provide enhanced imaging capabilities with very high-resolution 35-centimeter imagery, combined with AI-enabled analytics. The week's remaining Starlink launches will continue SpaceX's rapid deployment of their internet constellation, with one launching from Vandenberg Space Force Base in California and another from Cape Canaveral in Florida. This intense launch cadence demonstrates the growing momentum in commercial space operations and the increasing reliability of reusable rocket technology. Next up today. Scientists have made a fascinating breakthrough in understanding our moon's earliest days, thanks to new analysis of rocks collected during the Apollo missions. By examining these lunar samples, researchers have pinpointed that our cosmic companion solidified approximately 4.43 billion years ago, a timeline that remarkably coincides with Earth becoming a habitable world. The key to this discovery lies in a unique substance found in moon rocks called creep, an acronym for potassium, rare earth elements, and phosphorus. This material formed as the last remnant of the moon's original magma ocean, making it an invaluable window into our satellite's cooling process. By analyzing the decay of a rare earth element called lutetium into hafnium within these rocks, researchers were able to determine that creep formed about 140 million years after the solar system's birth. This timing tells us that the moon was still cooling and crystallizing while being bombarded by leftover planetary debris from the solar system's formation. What makes this finding particularly significant is how it aligns with Earth's own timeline. The impact that created the moon was likely the last major collision Earth experienced, potentially marking the beginning of our planet's transformation into a stable, life-supporting world. This new dating method not only helps us understand the moon's evolution, but provides crucial context for Earth's early history as well. These findings come at an exciting time, as future Artemis missions to the lunar South Pole could provide even more samples to study, potentially confirming whether this creep layer exists uniformly across the moon's surface. Have you ever wondered what would happen if a microscopic black hole passed right through your body? Well, a fascinating new study has tackled this exact question, and the results might surprise you. While most of us would assume instant destruction, the reality is more nuanced. The research focused on primordial black holes, theoretical objects that may have formed in the universe's earliest moments. These would be far smaller than the stellar black holes we typically think of, ranging from the mass of an atom to several times Earth's mass. For a black hole to be potentially lethal, it would need to be in the same mass range as asteroids. The study examined two main effects: tidal forces and shock waves. While the tidal forces from such a tiny black hole passing through your limbs or torso might only cause localized damage similar to a needle, a passage through your brain could be fatal due to the delicate nature of brain cells. But the real danger would come from shock waves. A black hole with just 1.4 x 10 circumflex 14 kilograms of mass could generate energy waves comparable to a .22 caliber bullet. Definitely enough to cause serious harm. Before you start worrying, though, here's the good news. Even if these primordial black holes exist, the chances of one passing through anyone in their lifetime are less than 1 in 10 trillion. So, while it makes for fascinating physics, it's not something that should keep you up at night. Let's revisit an old friend now. New research is shedding light on the mysterious origins of Oumuamua, that bizarre interstellar object that briefly visited our solar system in 2017. Scientists have been puzzling over how such an unusual object could have formed, and now they might have an answer. Using numerical simulations, researchers have found that solar systems with giant planets could be the perfect breeding grounds for Oumuamua-like objects. The key lies in a process called tidal fragmentation, where a large comet-like body passes too close to its star at high speed, shattering into elongated shards. What makes this particularly interesting is that these fragments would have a unique composition, a rocky outer shell with subsurface ice hidden within. This could explain Oumuamua's peculiar behavior, combining both asteroid-like and comet-like properties. The study suggests that systems with Jupiter-sized planets at reasonable distances from their stars are especially good at producing these objects. However, the rate at which they're created still doesn't quite match what we'd expect to see, suggesting there might be more to the story. Multiple planet systems might be even better candidates, as they're more efficient at ejecting objects into interstellar space. So while we're getting closer to understanding Oumuamua's origins, it seems this cosmic wanderer still has some secrets left to reveal. Finally today, in a fascinating twist on our understanding of planetary formation, astronomers have discovered that some planet-forming disks are refusing to grow up, quite literally. These disks, now nicknamed Peter Pan disks, are being found around low-mass stars and are lasting far longer than conventional theories suggest they should. Using the powerful Atacama Large Millimeter Submillimeter Array, scientists have found these disks are still rich in planet-building materials even after 30 million years. That's 3 times longer than the typical 10 million year lifespan we expected. Even more surprisingly, they're packed with hydrocarbons and show chemical signatures never before seen in such mature disks. This extended lifetime could completely change our understanding of how planets form around smaller stars. The longer these disks stick around, the more time there is for planetary cores to build up and for complex chemical processes to unfold. It's particularly intriguing because these conditions might favor the formation of planets with unique characteristics, possibly including worlds with carbon-rich atmospheres similar to Saturn's moon Titan. While these Peter Pan disks appear to be rare, with only 9 discovered so far, they might not be as uncommon as we think. It's possible we're just limited by our current observational capabilities, and many more of these eternally young disks are waiting to be discovered out there in the cosmos. And that brings us to the end of another intriguing episode. This has been Astronomy Daily with Anna. For all the latest space and astronomy news from around the internet, visit our website at astronomydaily.io. There you'll find our constantly updating newsfeed and can listen to all our back episodes. Stay connected with us on social media. You can find us by searching for Astro Daily Pod on Facebook, X, YouTube Music, and TikTok. And don't forget to subscribe to the podcast, wherever you get your podcasts. Details on all of this can be found on our website. Until next we meet, keep looking up. You never know what you might see out there in the cosmos. See you tomorrow.